BCIT Engineering Materials Modulus of Elasticity using extension. The objective of this lab is to determine the modulus of elasticity of a rectangular steel bar by calculating and plotting stress versus strain. This is the steel bar that will be used in the experiment. It has a width of 0.5 inches and a thickness of 0.125 inches. Those two dimensions are used to calculate the cross-sectional area perpendicular to the tensile loading. Loading is done on this apparatus, which consists of a loading frame on the left and a control and readout unit on the right. The bar will have been mounted in the grips when you come to class and an extensometer attached to the steel bar. Controls for the movement of the lower grips are on the right, as well as the speed adjustment. Above this are the load readouts and a reset button that will be used at the end of the experiment. The way this works is the upper grips remain stationary while the lower grips are moved downward. This puts the bar in tension. Measurement of extension is done by the extensometer, which is attached to the steel bar at 2 points 2 inches apart. This is called the original gauge length. On the front of the extensometer is a dial gauge that reads in increments of 1/10,000th of an inch. It's read from the top 0 position, moving clockwise. Controls for the lower grips consists of 3 buttons, a button to raise it, a button to lower it and thereby provide tension, and a stop button. Speed is set at 0.05 inches per minute. The load readout has 2 load readouts, a live load and a peak load. Notice that the load is a little bit above 0 as we need some tension on the bar to ensure it stays in the grips. This is our start position. So when we're ready to start the test, we check the load readout, ensure that it's at that initial position, and that the dial gauge is set to 0. We then press the lower button to put tension on the bar. Keeping your eye on the load readout, take it up to about 300 pounds and then press the stop button. Notice that the live load decreases a bit as the tension in the bar must be distributed throughout its length. Once it's stabilized, record the live load and the reading from the dial gauge on your data sheet. The dial gauge reading here is about 3/10,000ths of an inch. Continue on. Our next readout is 600 pounds. Wait until the live load stabilizes, take the load reading and the extension, record it, and continue on in increments of 300 until the final load of 2,100 pounds is reached. At the end of the test, we want to reset that lower grip, so we press the upper button to raise the grip, and we take it back to the initial position. The peak load will have remained at its maximum, so press the reset button to take it back to the initial readout. The dial gauge reads at 0 because this was elastic movement in the bar. There's been no permanent deformation. Information is recorded on the data table. There's a load column, elongation column, stress and strain. You've recorded the load and elongation. You'll calculate stress and strain. Stress is calculated by dividing force over area. There's our first force reading over the cross-sectional area, giving us 4,672 psi. Strain is calculated as a change in length over the original length. So there's the first extensometer reading over the gauge length, giving us 150 times 10 to the minus 6 for strain. There are no units as we're dividing inches by inches. Stress is plotted versus strain on a best fit curve, and the slope of that curve is calculated. The expected value of this slope is 30 times 10 to the 6th psi. This number is the modulus of elasticity for steel.